Okay, in this video, we're going to begin chapter 6, where we're going to put statistics to work. And in section 6A, we're going to talk about characterizing data. We'll talk about measures of center in this particular section, 6A. Okay, the distribution of a variable refers to the way its values are spread over all possible values. Here we can display a distribution with a table or a graph. Okay. And now, we'll start off with the measures of center in a distribution. There are three types. One of them is the mean, the other one is the median, the third is the mode. The mean is what we most commonly call the average value, and it is defined as follows. Here, to find the mean of a set of data, we're going to take the sum of all the data values and divide that by the total number of data values in that data set. And then the median is going to be the middle number in the sorted data set, or halfway between the two middle values, if the number of values is even. So to find the median, you have to sort the data set from least to greatest. And then the mode is going to be the most common value or group of values in a distribution. Here, for a mode, you may have no mode, or you can have one mode or more than one mode in a data set. Okay, here's the first example of that. Okay, in this case here, we're going to do this. Here, the number of words defined on randomly selected pages from a dictionary are shown below. Find the mean, median, and mode of the listed numbers. And these are the listed numbers that we have here. Here we got 62, 79, 76, 57, 38, 63, 61, 70, 65, and 39. Now, before we do anything, the first thing I would do is place these numbers in numerical order from least to greatest. Okay, so in this case here, I'm going to put 38 first, then 39, 57, 61, 62, 63, 65, 70, 76, 79. Here I'm putting them in numerical order. Okay, that's the first thing we do here. And then now we're going to answer the question, what is the mean? Well, to find the mean, you have to take the sum of these data values and divide that by how many data values that you have in that data set. So I'm going to use my calculator here. And I'm going to add these numbers together, 62, 79, 76, 57, 38, 63, 61, 70, 65, and 39. If I add those together, I'll get 610. That is the sum of all the values. And then we're going to take that 610 and divide that by the number of data values that we have in this set. Here, if I count these, you'll see that I have 10 data values. So here I'm going to take 610, divide that by 10. And you'll end up with 61. So the mean, now they say round to one decimal place as needed. In this case, it'll be 61.0. And then second is, what is the median? Well, the reason why I had placed these data values in numerical order is because to find the median, you have to sort the data set put it in numerical order from least to greatest, and then find the median. And that's going to be the middle number, or halfway between the two middle values here. So to find out what the middle value is, I'm going to cross out the first and the last, and I'm going to keep crossing out the numbers on the end until I get to the two middle numbers. In this case, it's going to be 62 and 63. So to find the median, it's going to be the average of those two middle numbers here. If I add 62 and 63 together and divide that sum by 2, 62 and 63 will be 125. 125 divided by 2 would be 62.5. So the median is 62.5. And then finally, what is the mode, or what are the modes? Now, in this case, there may be more than one mode. There may be just that one mode, or there could be no mode. In this case, each number occurs only once. Okay, there is no number that occurs the most frequent. So, there is no mode. Okay, let's look at another example of this. All right, in this case here, body temperature in degrees Fahrenheit of randomly selected normal and healthy adults are shown below. Compute the mean, median, and mode of the data set. Okay, first of all, I'm going to place these numbers in numerical order as well. So here I'm going to put 98.1 first, 98.2, 98.5, then 98.6, and then 98.7, 98.8, 98.9, 98.9, 98.9, and then finally 99.0. That's the data set in numerical order from least to greatest. Now we're going to find the mean of that entire data set. Okay? So here I can use this data set or use that sorted data set. Doesn't matter when you find the mean. It does matter when you find the median. Okay? So here if I add 98.7 plus 98.8 plus 98.1 plus 98.2 plus 98.9 plus 98.5 plus 98.9 plus 98.6 plus 98.9 plus 99.0. That will give me 986.6. Now, if you count the number of data values here, there are 10 data values. So that 986.6 divided by 10 will give you 98.66. And in this case, we'll round to the nearest 100, or the two decimal places. And as you can see, that answer was already to two decimal places. So the mean is 98.66. Now we're going to find the median of this sorted data set. Okay, so like I did in the last example, we're going to cross out the first and the last numbers. We're going to cross out the numbers that are on the end, on the left and on the right, until we get to the middle. In this case, now we got two middle numbers, 98.7 and 98.8. So to find the median, we take the 98.7, add that to the 98.8, divide by 2. Now if I add 98.7 to 98.8, I'll get 197.5. Divide that by 2, and this is going to be to the nearest 100, 98.75. That would be the median, 98.75. And then what are or what is the mode? There might not be a mode, there may be one mode, there may be more than one mode. That's the number that occurs the most frequent. And in this case, 98.9 occurs 3 times in that data set. So the mode is actually going to be 98.9 degrees Fahrenheit. Okay. All right, now let's talk about effects of outliers. An outlier in a data set is a data value that is much higher or much lower than almost all other values. An outlier can change the mean of the data, but generally does not affect the median or the mode. Okay? So that outlier can have an impact on the average of that entire data set. Okay? But for the mode and the median, there's no effect on that. Okay? Look at example 3. It says here, the following data give the margin of victory for a football championship over 15 years. Okay, and there's that data set given to you: 13, 8, 4, 11, 12, 33, 3, 26, 8, 4, 3, 4, 6, 14, and 4. In part A, you're going to find the mean and median margin of victory. Mean and the median. And what I would do here is to go ahead and place these data sets and these data values in numerical order. So here, I'm placing these numbers in numerical order. Okay, now we're going to find the mean. We're going to add these data values together and divide by how many data values we have. So if I add 13 plus 8 plus 4 plus 11 plus 12 plus 33 plus 3 plus 26 plus 8 plus 4 plus 3 plus 4 plus 6 plus 14 plus 4, that sum is going to be 153. And let me count how many data values I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here I got 15. So I take 153 and divide that by 15. And that will give me 10.2. That would represent the mean. And to the nearest tenth, it's already to one decimal place, it'll be 10.2. Now for the median of that data set. To find that out, I just cross out the numbers on the end, on the left and the right until I get to the middle number. In this case, it's 8. Okay, so here the middle number is 8. So the median of that data set would be 8. Okay, now on the next page is part B, where it says here, which, if any, of the margins of victory would be considered an outlier? Select the correct answer choice, and if necessary, fill in the answer box to complete your choice. Well, if you look at this sorted data set, the outlier is going to be the one that's going to be far away from the other data values here. In this case, I'm going to say 33 is the outlier. Okay. So here the outlier there would be 33. And then next they're going to ask you to find the mean with the outlier excluded. Okay? So if we were to exclude the outlier 33, and in fact, if I go back to that sum that I came up with, it was 153. That was the sum of all 15 data values here. If I take away 33 from the 153, I'm going to get 120. And by taking away that outlier 33, instead of 15 data values, I will have 14 data values. So I need to take the 120, divide that by 14. And to the nearest tenth or to one decimal place, I would round that off to 8.6. Okay. Because I remembered that sum was 153. So subtract the 33, which is the outlier, from the 153, you'll get 120. And instead of 15, you're going to divide by 14 because you've eliminated that outlier. And now find the median with the outlier excluded. Well, if we exclude that outlier, this is our data set. So we've excluded the outlier of 33. Now, we're going to use that data set to find the median. I'm just getting rid of the numbers on the left and on the right until we get to the middle number. In this case, we got two middle numbers, 6 and 8. So now to find the median of that data set, add 6 and 8 together and divide that sum by 2. If I add 6 plus 8, that will be 14. 14 divided by 2 will be 7. So the median without that outlier would be 7. And by the way, you could have found the mean by using that sorted data set without the outlier. Just add them up, and this time you'll divide by 14. Okay. Now let's talk about the average, the word average, and how that can be confusing. The different meanings of average can lead to confusion. Sometimes this confusion arises because we're not told whether the average is the mean or the median, and other times because we're not given enough information about how the average was computed. Okay, so in example 4, for the following distribution, decide whether you expect the mean, median, or mode to give the best representation of the center of the distribution and explain why. Like here, per capita earnings in New York City. And usually they will use the median as a way of determining what they call the average here, per capita earnings, because, you know, per capita earnings could be small, and in some cases you may have large numbers for per capita earnings. Okay, so we use the median since it's unaffected by outliers in this case. Okay. This next example, age at first marriage for women in the United States. We want to decide whether we expect the mean or the median or the mode to give the best representation of the center of the distribution. Okay, now, for some people do get married probably in their 60s or their 70s. Most do get married in their 20s or 30s, but you may have some that might be in their 60s or their 70s when they get married for the first time. So here, we would expect to use the median as the center because it is, again, unaffected by outliers. Okay. All right, the next example, daily snowfall in Omaha in January. Will we expect the mean or the median or the mode to give the best representation of the center of the distribution? Okay. I think we would expect for them to give us the mean, okay, because we're accounting, excuse me, we're accounting for all the days regardless of the amount of snow. Okay, so we would expect for them to give us a mean, which is going to be the average of all 31 days in January. Okay. All right, let's talk about shapes of distribution. We next turn our attention to describing the overall shape of a distribution. We can see the complete shape of a distribution of a graph because we are interested in the general shapes of the distributions. It is easier to focus on smooth curves that fit the data rather than dealing with the actual data. Okay, so on this next page, this is what a few distributions would look like this one right here. So here for the number of modes, here we got two single peak distributions. Here we only got probably unimodal, only one mode, as you can see in this case here. But like a double peak distribution or a bimodal distribution, here we see two peaks here, or two humps in that particular situation. Okay. Now, in a distribution, it could be symmetric or it could be skewed. So that's the next thing we'll look at. Symmetry or skewness. First of all, for symmetry, a distribution is symmetric if its left half is the mirror image of its right half. In this case here, this is considered to be symmetric. Here, the left half has the mirror image as the right half. And by the way, if you were to fold the paper along this line right here, the right half will be on top of the left half. That's what we mean by symmetric. And when it's symmetric, the mode, the median, and the mean are equal to each other. Okay? The mode, the mean, and the median are equal to each other. Okay? Let's say a distribution that is not symmetric. It must have values that tend to be more spread out on one side than the other. In this case, we say that the distribution is going to be skewed. Now on the next page, you'll see illustrations of what left skewed looks like and what right skewed looks like. A distribution is left skewed if its values are more spread out on the left side. And you can look at this and tell that the end on the left is skinnier than what's on the right. Okay. And if you think of a skewer, it's that point that you use to place your food in. Here, if that point is kind of on the left, it's left skewed. Okay, and the outliers are going to be low values here. And in this case, your mean will be less than the median, and the median will be less than the mode. Now, on the other hand, if we have a right skewed, a distribution that is right skewed would be where the values are more spread out on the right side. Here, your outliers are going to be on the right side. The skinny part of that distribution will be on the right end, on the right tail. And in this case, your mode is going to be less than the median, and the median will be less than the mean. Or in this case, we can say the mean is greater than the median. Okay. And pretty much we already talked about this. A single peak distribution is symmetric if its left half is a mirror image of its right half. A single peak distribution is left skewed if its values are more spread out on the left side of the mode, and a single peak distribution is right skewed if its values are more spread out on the right side of the mode. Okay. And now we'll look at variation. Variation describes how widely data values are spread out about the center of a data set. Okay? For low variation, it will look like this. If your variation, how it's spread out, if it's low, that means that this hump is going to be tall and skinny, as you can see here. Tall and skinny is going to be a low variation because there's not much spread in that data set. Moderate would be something normal like this one right here. But for a high variation, if you notice, this hump shrinks. The smaller this hump gets, that means that there is more variation here. Okay. So as you can see from left to right, these three distributions have increasing variations. That means the data set or the data values are spread out more and more and more. Okay, now let's look at this example. Consider the distribution of exam scores, graded from 0 to 100. For 79 students, where 35 students got an A, 26 students got a B, 18 students got a C. Complete parts A through D below. Now in this case here, how many peaks would you expect from the distribution? Okay. In this case, it would be this choice right here, where there would probably be one peak, because there are no obvious reasons why the exam scores would form different groups. Okay. So here we only have like one peak. And in part B, make a sketch of the distribution. Well, here they're giving you a choice of sketches. You'll want to pick the one that would fit that particular situation here. And looking at this, it would be this one right here. Because we got 35 A's, 26 B's, and 18 C's. So it will look somewhat like this for a distribution. It won't be normal. And then part C, what shape would you expect for the distribution? And because many people got an A and very few got C's, I would expect for that distribution to be less skewed. Okay. And if this is the case, that would be like this right here. This will be less skewed because very few people got a C and many of them got an A. Okay, part D. What variation would you expect in the distribution? And you have to pick the one that would best fit. In this case, it would be this one right here. The variation would probably be large because many students got an A, some got a B, and a small number got a C. Okay, so we can see that the data would not be clustered. Okay, let's look at another example of something like this. Consider the distribution of the monthly sales of snow shovels over a one-year period at a store in Boston, Massachusetts. The distribution would look best if you start from July rather than January. And here we're going to complete parts A through D. How many peaks would you expect for the distribution? Well, if we're starting from July, I would only expect like one peak corresponding to the winter months. Okay. And then part B, you'll make a sketch of that distribution. Okay, in this case, based on the winter months, I would expect for it to be what they call a normal distribution, which is going to be graph A. And part C, what shape would you expect for the distribution? In this case, oops, wrong one. It's this one. The one that I selected is the distribution will probably be symmetric because the distribution of monthly sales of snow shovels has its peak in the winter months because of the need for snow shovels then. So during the peak in the winter months, it would expect to be symmetric or normal. And then what variation would you expect in the distribution? I would expect for it to be large because there would likely be several months with very different numbers of snow shovels being sold. Okay. And that's particularly going to be during the winter months or the winter season. Okay, let's look at example 9. And that will wrap up this particular section. Exam results for 100 students are given below. For the given exam results, briefly describe the shape and variation of the distribution. Here we got a mean of 75, the median also 75, the low score is 60, and the high score is 90. And you want to describe the shape of the distribution and choose the correct answer here. In this case here, if you look at this, the median and the mean are exactly the same. So that tells me I'm going to have a distribution that is symmetric. Okay? If you recall, when we went over this, the mean and the median are the same. That means it is symmetric. So here we have a distribution that is symmetric because the median is equal to the mean. And then we're going to find the difference between the greatest and the least scores. Well, here's the high score, 90. I'm going to write this out. The high score minus the low score. Well, the high score is your 90. The low score, that's given to you as 60. 90 minus 60 is 30. So the difference between the greatest and the least scores is 30, which is either moderate to large or small compared to the number of students. Well, compared to the number of students, that would be small. The variation is small compared to the number of students. Here we got 100 students that we're dealing with. Okay. All right, so that will complete this video on characterizing data.